Going to interpret some slope here, guys. We're going to start out with this table. Our table here is delivery service charges, and we have miles traveled versus charge. When we look at slope, we need to understand that our slope is a ratio between our dependent variable versus our independent variable. If we look at this situation for delivery service charges, we need to ask ourselves which of these is our independent versus dependent variable. If we look at this and say, do miles traveled depend on the charge, or does the charge depend on the miles traveled? And hopefully, you're saying that the charge depends on the miles traveled. And if that's the case, that means that this here is our dependent variable, whereas this here is our independent variable. So miles traveled, or charge depends on miles traveled. And so when we're looking at our slope, we're going to say our dependent variable over our independent variable. We're looking at a ratio between these two values, whatever they end up being. Looking at this situation, it looks like our charge is $7 each time that we are looking at this situation, plus 7, and then the miles traveled increases by 1 each time. So that tells me that my charge, or my slope, is $7 per 1 mile. So we have a context for our slope of $7 per mile. And that context is what matters for these problems. I want to make sure that you understand that sometimes we'll have x's versus y's and we won't have any context to our slope, but if there's a real life situation, your slope will end up having some labels to it, and those labels, that ratio between, in this case, $7 per 1 mile, is what we are comparing in this situation. Let's finish up my mile. Now let's look at this other scenario here, so we can look at this. We have weight in pounds versus length of spring in inches. So I'm guessing this is some sort of machine of some kind, and a weight is being pulled on a spring. It probably looks something like this. Here's a spring, and here is this is what I'm visualizing, a weight hanging off of it. And it's pulling on the spring. Depending on how much weight, the spring will get longer and longer. So we need to ask ourselves again, what is our independent variable versus our dependent variable in this situation? Does the length of spring depend on the weight, or does the weight depend on the length of the spring? And I would have to say that the length of the spring, how long that spring stretches out, depends on how much weight we are attaching to it. So now let's put some numbers to this. It looks like the length of the spring is increasing by 0.8 inches each time. We can do that over and over and over. And it looks like my weight in pounds is increasing by 1/2. I like this problem because we're going to have to deal with some decimals and put them into context of a fraction or something like that, because our final answer cannot be this funky decimal thing. So our dependent variable increase, our change there is 0.8 inches, and our independent variable change is 0.5 pounds. Looks like we need to, I'm going to multiply both of these by 10 so I can get them into whole numbers on the top and the bottom. So I get 8 inches per 5 pounds is my slope. And I can either write it as 8 inches per 5 pounds, or I could also write it as 8/5 inches per pound. But again, this context here in this label is what I am caring about. I care that you understand that this label exists, and it is going to be a ratio of our dependent variable over our independent variable labels. Okay? All right. You have a couple more videos that you're going to watch in this in this lesson before you start in the must-do practice problems. But make sure you do the must-do problems and make sure you complete the exit pass at some point today. Thanks for watching.